AI with Michael Nygard.
The AI DevOps podcast is a show for those shipping software using AI, .NET, Azure, and DevOps. Each show brings you hard-hitting interviews with industry experts, innovating better methods and sharing success stories. Sponsoring the podcast is ClearMeasure, a software architecture and engineering firm that implements AI to empower software teams to establish quality, achieve stability, and increase speed. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that AI, Azure, and the .NET ecosystem has to offer. My guest today on the show is Michael Nygard, and he advises consulting firms and private equity firms, CTOs, CEOs, and boards when they require senior technology judgment for limited-term, high-impact solutions, including architecture assessments and platform rescue, cloud and data center, data cost interventions, much more. AI engineering enablements, technical diligence, divestiture and carve-out architecture, and operating model redesign. He has over 35 years of experience, and his career is still going, and he's worked at really at the seam where people and processes and organizations and the systems they build intersect. Most organizations treat those as separate problems. The hardest failures and the most consequential wins live precisely where they interact. And that through line is what Release It, his published book, is fundamentally about. And the vocabulary it introduced, like circuit breakers and bulkheads, stability patterns, those are really now standard in the industry around reliability. And the book is widely cited as foundational to DevOps and cloud native practices. He's had senior roles at other companies like Nubank, where he led a data business unit with over $300 million in annual spend, and he served as chief architect with a reach across 2,500 engineers, while the customer base grew from 75 million to 125 million across multiple countries and regions. And he's done just so much more that can be listed. But I'm really excited to have Michael on the podcast. So welcome, Michael. How are you, sir?
I'm doing very well. Thank you. Happy to be here, and thank you for that fantastic introduction.
Oh, my pleasure. My pleasure. Well, that's just a snapshot of all the things that you've done. So I'm really excited to have guests like you on the show. But before we can really dig in, I always like to ask the guests just to kind of go back in time. You have a long and continuing career in software. What is it about making computers do interesting things that like gripped you early on and has remained interesting all these years?
Wow, that's a fantastic question. Always great to go like straight to a person's deepest motivations. I think there's really been two parts that have kept me motivated and going. One is this ability to create something out of pure thought and make it become real. It is a creative and an artistic endeavor that I really enjoy. And the other thing is that basically since the personal computer era, I started with the 8-bit micros. And since that personal computer era, we've had these as tools for putting more capability and more power in the hands of the individual and sort of empowering people to do more and achieve more and reach their potential better. Now, unfortunately, it is also possible for these machines to be used as, tools for control and suppressing those abilities. That's not the part of the industry I favor.
Yeah. Well, there's so much that we could talk about, but this being an AI show, you've got some opinions, and you've posted recently on LinkedIn and online about what AI changes in the software process. And of course, your book, Release It, has a whole lot of patterns that are very useful. And all of that was pre-large language model adoption like we had just in the past, really, year. And so in just at the highest level, what do you think this generation of AI tools changes in just the general software development lifecycle? And what stays the same?
I think there are some things we are already seeing. Certainly, removing coding as a bottleneck from any creative process is powerful. Another effect that's not talked about as much is the ability for people to re-generalize or become generalists again. Over time, we've had this subdivision and subdivision into finer and finer niches. So, not just a programmer, but a front-end programmer, a front-end React programmer, a front-end React TypeScript programmer. This narrowing, on the one hand, means that they are very, very good at those specialties. But on the other hand, it means to accomplish a full product, you need to bring together a lot of specialists in order to cover all the skill sets you need. Well, the LLMs are pretty good gap fillers. They may not do as well in each specialty as a specialist would, but they do well enough that you can have people covering much larger areas. And this, on the one hand, is driving some of the fearful reactions and some of the over-aggressive actions by executive leaders, where they look at a product and say, maybe I don't need a team of 15 or 20 people on this. Maybe I need 2 or 3 or 1, because one person with a fleet of agents can cover a much larger surface area.
Yeah.
But the other thing that we need to think about is how does it refactor, or how does it change the forces that drive one team topology over another team topology? In other words, do we need as many platform teams if the product team can just direct their agents to build out the platform-like pieces that they need? Do we need shared library teams if you can cheaply regenerate the shared functionality? I think we haven't really seen the full development of the responses to those forces. We're beginning to see the forces, but it's going to take some time to figure out what that means as far as the shape of the team, the shape of the organization, and the work of the individuals.
Yeah. And speaking of the shape of the team, just, what was it, a little over a month ago, you put a article on your website called AI versus microservices, and kind of reflected back on what were the forces at play when people started favoring microservices and started talking about the trade-offs from monolith, and of course, looking back, what was it, over 20 years ago, at the service-oriented architecture push, and then the rebellion against that. And so we'll include a link to that in the show notes, but for people who haven't read the article, what are your big thoughts that you think everybody needs to realize when looking at the forces of AI and the macro architecture patterns that they evaluate?
Again, I think this is an area where the full story is not yet written. That piece and a few others that I have in the queue, aside from being a little bit provocative in the title,
Sure.
They are meant to re-examine, why do we care about architecture in the first place? In workshops, I've long used this kind of thought experiment that said, if you could recreate any system in your company in a day, would you actually care about the architecture of that system? And the answer is probably not.
Yeah.
We care about architecture because we're trying to balance present day build cost, future operations cost, future maintenance cost, future cost of change. If you bring all of those costs to near zero, maybe the internal architecture doesn't matter as much. What matters more at that point is, how are the different systems within your enterprise or across enterprises, how are they structured and interacting? And so you're worried more about the exterior architecture of your system than the interior one. And that in turn means we're going to think a lot about the surface area that we're exposing, APIs, MCPs, text artifacts increasingly over programmatic or binary ones. And we need to make the structures evident and explainable and interpretable by low context entities. In other words, the people interpreting these systems aren't carrying 10 years of latent knowledge about how the company does its business. They're always the new guy trying to figure things out from documentation.
Right. That is true. And so many people are predicting, and it seems reasonable to agree with the prediction that that AI has already started and will have this hockey stick of an explosion of software and code that's out there in the wild running in production compared to the amount of code that has been. It seems like this is just, it's not going to continue on its current trajectory, but it's accelerating. And so with that dynamic, how can any professional computer programmer know you're always going to be going into code that you don't have loaded up into your brain. And then of course, wanting the machines to do some things. So microservices, one of your premises is in a monolith, nobody gets fired when you delete a class, but in a microservice, if you've organized the teams around it, then hey, if you don't need that, it might be a team going away. There's so much more that we can do. I'm reminded of Fred Brooks's Mythical Man Month book, where he talks about the surgical team, where a surgeon and an assistant surgeon are basically doing the operation, and you got some assistants around. What's your thoughts? It seems like, do you agree that we may be actually getting to that point where you put a couple of really good software engineers together, and they can do a lot of things with modern tooling?
Absolutely true. In fact, as you were describing that, I was suddenly thinking, oh yeah, we kind of now have the surgical team model, right? Except they're all LLM driven, operating as a halo around the chief surgeon. I think that plus the explosion of code, we have interesting times ahead. I mean, we are in interesting times, but we have more interesting times ahead because code is not an asset. Code is a liability. Undeployed code is risk. It has unknown bugs. Every change has risk. And so if you vastly increase the amount of code and the change frequency, without changing anything else, you're going to get a huge increase in number of bugs, severity of bugs, sort of opportunities for failure. Mm-hmm. So we have to create compensating controls that prevent those risks from manifesting. I view that as sort of an obvious problem. And I don't tend to worry too much about the obvious problems because everybody sees the obvious problems. And so lots of people are working on solving those. I think the questions around code ownership and the ability of very small teams to accomplish things become interesting because, agents are still pretty aggressive about rewriting large pieces of code on a frequent basis. Mm-hmm. And so if you have multiple people in the same code base, it's very easy to get large scale merge conflicts and difficulty in having parallel work. At the same time, there's a lot more that goes into creating products than just the coding and programming work and at the core of product development. Especially in a large enterprise, the process of getting something out into the market is pretty extensive. If you're only speeding up this one part and making it, much bigger and much faster to do that, you've moved the bottleneck to other places in the process. And so now you may have a situation like the Uber CFO saying, we've spent our year's budget of tokens in the first quarter, and I don't see a correlation to value delivered.
Right.
Well, that may be because all of the stage gates between product development and production and the customer are preventing you from getting that value. I feel like I'm on a little bit of a ramble, so feel free to steer me back. But one of the other things I expect to see in most organizations, we're seeing a lot more coding-like activity from previously non-technical individuals, which on the one hand is great. Self-service, empowerment, that's fantastic. The part that I worry about is they're often creating dependencies on things that they aren't aware they're creating dependencies on. So we've seen every time Claude adds a feature, we see another SaaS company's stock price tank because there's a fear that they're going to get displaced.
Yeah.
But actually, a lot of these SaaS companies are now the secret back end to agent-driven integrations that have been created near the front end.
Yeah.
But they're not documented. They're not known. They are business critical infrastructure now, and that's sort of an unmanaged risk that I'm seeing.
Yeah. I remember long ago, a lot of discussion and debates and even university lectures around the concept of some systems being a system of record and some systems being a system of interaction. And the systems of interactions have much shorter lifetimes than the systems that were systems of record. And what you just pointed out is Claude, if it's just stitching together a bunch of systems of record, then by definition, that is a system of interaction. Whereas, all those back-end dependencies that are systems of record for something, they're gonna be there. If they go down, there's bigger consequences. And not understanding all of the dependencies, that sounds like an architecture problem.
It does indeed. And it also quickly becomes a compliance problem as soon as you have to pass an audit of any kind. One of the first things you have to deliver is documentation about all of the systems that are in scope for the audit.
Right.
And maybe the answer is we don't know anymore what all systems are in scope for the audit.
Well, that can't be the right answer.
It's a temporary answer.
So you touched on the Uber issue where the value wasn't there, and you also put it on your website an article called AI versus throughput, where you can do a whole lot of things, but if the throughput is not there, and throughput's not a new problem. I mean, there's been so much work through the Agile and Kanban and lean software development. So much work around figuring out how to optimize throughput, and the digital factory model, stations of work, and what's next, and measuring all that. So, in your view, does the AI tooling invalidate any of the steps that have previously been analyzed in theory of constraints and Kanban and all these other methodologies?
I actually think it makes the theory of constraints much more relevant and important.
Okay.
It was always relevant, but for our listeners who may not be familiar with it, the theory of constraints says there's exactly one constraint that limits the throughput in your process. And if you increase the production upstream of that constraint, all you're doing is accumulating inventory. And inventory has a carry cost. Inventory has a risk of obsolescence. It has a risk of defects that are undiscovered as yet. And so building up more and more inventory before that step is not helpful. Organizationally means there's no additional throughput, just extra cost and risk. In a lot of organizations these days, the bottleneck stage in getting something into production is actually the capacity of CI and CD pipelines. We see a lot of companies are maxing out their GitHub Actions, they're maxing out their Tekton task runners, and there's a fixed delay because we have shifted left with so many things and put it all into the pipeline that now it takes 45 minutes, an hour and a half to get feedback on the code you just pushed.
Yeah.
So generating more and more code ahead of that bottleneck step isn't really going to increase your throughput. So I do think these really old techniques like value stream mapping are still highly relevant. Another thing, this is a peek into an upcoming post. Another thing that we have to look at is in an organization made of multiple teams, there's usually not one linear process. It's usually a flow network of many different teams generating work that then has to be further processed by other teams. Well, if a supplier team triples its output, that means the downstream team must consume triple the input. And so they're sort of using all of their capacity just to keep up with the overall increase.
Yeah.
What you really need to see is a place where you have teams that are able to increase their output and have a sublinear increase in the work done by others. Now, this is the realm of the platform team, right? If you have a well-functioning platform, then the platform team ideally doesn't need to scale at all as consumption of the platform increases.
Mm-hmm.
Most companies internally, that's not really how it works. But hopefully it's not, supralinear, at least. You'd like it to be sublinear scaling of the platform team relative to the consuming team.
Yeah.
So this is where I think looking at team topologies as a technique and a lens for examining the flow network of work in your company, I think that's a very powerful tool, and one where you can deliberately look at certain interactions and say, we are requiring too much coordination and communication between these teams. We need to create an isolation layer and a platform boundary so that they can scale independently of them.
That you're right. The AI tools, there's no awareness of any of these concepts. It's just generating tons of code. And I'm reminded of some of the really old computer systems where even adding a new field was a big deal on some systems. And even today, you add one field and you have to change so many different layers, so many systems. But product management or the architects, they can say, okay, how do we quickly get this concept of what year, I don't know, or what month, and if you embed the year and month into a SKU number or an order number, you can get that feature into the system without adding a new field. Because
data smuggling.
Sure, yeah. I mean, just so many things of, okay, I need to get this feature into the system, but how do I do that with as few with as little internal work? And these AI tools, just with a prompt, there's no concept of that whatsoever. The code just starts spewing out, and then you're right. Well, somebody has to review it, and then we have to test it. And now how many modules, how many deployed things have we changed? What's the testing burden? You're right. So many of those things.
It's shockingly difficult to convince an LLM not to change the API that you expose to callers within your system. And every time you do change that API, unless you're doing it in a particular accretive, backward compatible way, every time you change the API, you're pushing work onto others. And so this is another place where there is a risk that we sort of spin up these flywheels of token burning machines, just pushing API changes back and forth and not really moving anything forward in terms of, customer value delivered.
But maybe you have a name for it. I think this is I think this is a big concept that everybody needs to hear in going for actual throughput, which is to the customer, to production. Every step of the way needs to have a less than linear relationship, input versus output. Every step should absorb and resolve work, not just do some activity on the work and take the same amount of work and pass it down. Or the worst thing to do is grow the amount of work.
Amplify it. Yeah. And in fact, in the classical Deming literature, one of the things to watch out for is failure demand, where you're pushing out defective work that has to get kicked back upstream, maybe even upstream of you, and increase demand on the whole process.
Right.
And that's another problem that we're not really controlling for at this point.
But as the whole industry, and it's even conversations that you have, the principles will start emerging. I mean, every movement that we've had has had people wrestling with what the forces are at play and how should we think about them, and then principles emerge.
Yes.
I mean, the agile principles emerge. Cloud, what was it? Cattle versus pets in cloud server management. That concept emerged. DevOps thing emerged, where keep the build short, do it all the time, test everything. Therefore, it has to be automated. I mean, just these principles start emerging. And it seems like this may be another one of those things where, yeah, we're going to use AI in the process, but it's not the right use of AI if it amplifies that work. We need to design it so that it, do no harm, don't amplify the work, and design it so that it resolves and reduces the amount of work flowing down.
I agree on multiple levels. We don't yet know what all of those principles are. And cloud is a great example, because I remember before we hit on the model of cloud that Amazon promoted with EC2, we had grid computing that various vendors were offering that was inspired by HPC scientific computing environments. There was utility computing that no one could actually define or deliver. It was sort of, colo with a bag over its head. There was fog at one point. All of these different metaphors were actually different combinations of some of the same elements: virtualization, workload over a network, moving your data to where or moving your program to where the data is, and so on. But a lot of them were sort of, in retrospect, obviously transitory experiments toward a combination of elements that made the model work. I'm sure if we look back at previous iterations, we'll see the same thing. Before we settled on the sort of IBM PC style architecture, the number of different kinds of PCs was weird and wonderful and very scattered and fragmented. And then the right things came together, some technology, some business, some market forces, and it just amplifies itself. We will see the same thing with the AI-driven, software-intensive enterprise. I think right now, at the moment, one of the things we're observing outside of, I'm trying to think how to describe this. If you look at the software developer community, so people who primarily built systems for a living up until 2022, there is a certain degree of fear, existential angst, worry about the nature of the profession. And then you go talk to everybody else in the enterprise, and they're like, this is great. I'm building all this stuff that I could never get IT to do for me.
Yeah.
Right. So it's dramatically lowered the cost of doing things. And so we're doing a lot more things. So there's a sort of explosion of pent-up, frustrated demand. I don't know if that's the new equilibrium or if that's a transient before we figure out, actually, maybe it is important to think about the surface area of your systems and the encapsulation boundaries and risk management of data that you're holding. All of those boring things that cause IT to be the department that says no all the time.
Right.
So I'm not sure where things are going to settle out.
Well, that analogy, I love it. Makes me think of something that is further downstream, just 10 years ago and certainly 20 years ago, and that was a software development team's ability to provision servers. We literally couldn't, and we had to go to some other group to say, hey, I need some new servers. And they had responsibility for production, but because it was servers and servers were expensive and hard, even getting a server for test was difficult. Even getting a server for a build was difficult. And then you had, the Dilbert cartoons with the preventer of IT services, comics and all that. But now with the cloud, yes, anybody can spin up a server, spin up a place to run some code, which is great for pre-production. It's like amazing for pre-production, but for production, okay, there's still some additional things. Yes, you can initially do that, but there's some other things that if you ignore, you're going to hurt down the road. I think same thing upstream. It's like, yes, you can prompt your way to something that'll do something, and that's great, but, and I think it's the same thing. It's like, what does it really mean to have a reliable software system that runs even when you're on vacation, even when you leave the company?
Or somebody closes the laptop that has the sticky on it that says, don't ever close this laptop.
Right.
Yeah, I think that's a good analogy. And we can probably look at some of the features that made that work and what resulted.
Yeah.
The ability for a departmental level dev team to use the admin's purchasing card to provision a cloud environment was liberating.
Mm-hmm.
And a couple of years later, we started talking about shadow IT as, this unmanaged risk being presented by a bunch of systems that were built, outside of the governance umbrella of the corporation.
Yeah. Which
I would say there's still a lot of shadow IT, but we've sort of reached an understanding that you can put some things out there that are like super close to the customer. They're changing rapidly. They don't really have that much ability to corrupt serious data. Nothing else is allowed to call those and depend on those. And you sort of say the surface layer is, it's a tier 4 system. It's not a tier 1 system that we're going to have, support calls in the middle of the night if things are not going well.
Yeah.
Maybe we arrive at something like that. You can use the low code, no code, SaaS platform as a service type of things to build the departmental apps, but the enterprise apps still need to be, governed and in the protective embrace of IT.
Yeah. Just like self-driving cars and any piece of equipment in our legal system, there's always an operator. There's always someone who's accountable for anything that this machine does. Even from if I loan my car to somebody and something bad happens, my insurance for that because it was my car. So it's the same thing with this. Even if someone who previously has never written any code produces some software, we have to ask the question, okay, who is operating that system? I think that's still a valid question. It doesn't go away.
Absolutely. And it's not just a question that companies are going to be asking themselves. It's a question that governments and law enforcement and regulators are going to be asking you.
Yeah. So as we close up here, I want to kind of close on one final topic under the umbrella of quality. And you mentioned different types of automated testing and the boundaries of unit testing, integration testing, or full system testing. And I'm even thinking of just external health checks, how that's morphed from cloud, where years ago it was, is it still up? Is it still up? Is it still up? And now we have patterns like tracer bullets and phantom transactions and that, constantly testing in production. And so in the world of AI-driven development, how has your thinking changed about how what types and how many, what distribution of automated tests we use in the quest for being able to always say, this version of the code base is still stable?
I think there are two things that I now regard as feasible and useful that I tried to avoid in the past. One of those is GUI-driven user interaction testing, which, we always kind of hesitated to do that in the rapid change world of agile development because, you don't have testers available at all hours, and now we do. Your testers are going to get sick of going through, 10 changes a day. Not these ones, right? So GUI testing is a lot more feasible and actually kind of makes the old argument about is it unit or integration testing, makes it moot. which I regard as beneficial. The other thing that I am thinking a lot about, but haven't seen put into practice as much yet, is type-driven testing for interfaces and externalizing interfaces from implementations. So I'm old enough that I remember things like Corba and RPC, where you had a whole interface definition language, and you might actually receive an interface from external to your project and be told, this is the interface you must supply, and these are the ones you're allowed to call. We may see a return of that with some attempt to say, we're going to define a type system that we require the LLMs to satisfy, but we're not going to allow them to actually modify the API. The API is going to be something that they receive from outside their domain of control. And those then become the fixed points that allow variation on either side of the interface. Right now, our type systems are not well equipped to deal with things across, many different code bases. But I see some potential there.
Yeah, I agree with the overall GUI testing. That's Playwright so much better than Selenium, and Selenium was kind of ruled the roost in so many contexts
for a long time.
Long time, and now I too have found myself just leaving an AI session, just doing exploratory testing with Playwright overnight and going to bed, and like literally saying, execute every variation of every screen and click on every button and see if anything blows up, because that's clearly a bug. If we get an error, I mean, that's some good coverage.
Yeah, definitely.
I wonder, you didn't mention specifically, but, and I don't know where I fall on this, or if we even know, is the practice of test-driven development, test first, as in writing a failing test in order to, help design code in the small. What is some aspect of that eliminated because we're not actually handcrafting in the small anymore, or if there's some element of that that's still useful?
It's a good question. I can say from my own experiments, whether I tell the agent to do test-driven, test first, test after, hasn't made much difference in the quality of the output. Maybe because they don't really have a mental model of the world. The test doesn't really guide the design. It's just more tokens being generated. And maybe if you have it strictly write the test with zero implementation, and then you iterate reviewing the test and saying, not quite right, not quite right.
Yeah.
Maybe it would get somewhere. But honestly, I've found it just as effective to have it be goal-oriented, and then I review the design afterwards, because large-scale design changes aren't as costly as they used to be.
Yeah.
So I can let it go for, 4 minutes, and then I say, no, I really want a command layer in there.
Yep.
And I let it go for another 4 minutes, and I've got a command layer. So much has changed with the cost equation that we do have to rethink some of our practices.
Yeah. And we'll close on this. You certainly have never been out of work because of a new technology advancement. And it seems like good engineers are always in short supply. And even though we may see some companies laying off something, and then the doomsday sayers, AI is going to make this whole category of job totally go away. And what are you telling the young computer scientists or passionate programmers up and coming in your world, when invariably they ask the question, so, well, you've had the career in this and I'm kind of interested, but is there a career for me?
When somebody is asking questions like that, telling them, I don't know what the future holds, is not very reassuring or inspiring.
Yeah.
I don't know the exact shape of what our profession is going to look like, but I don't think it's going away. I think whether it was Dario or Sam who first made the prediction, like in 18 months, all white collar jobs are going to be gone.
Sam Altman.
That was like 3 years ago now, right?
Yeah.
So they're not gone, but they're different and they're changing rapidly. What we may see is a different classification or different breakdown of the kinds of jobs. So there are some people who are let me think how to say this. You may need to edit out some hemming and hawing here.
That's fine. I did a quick search. It looks like Dario from Anthropic said that 50% of entry level white collar jobs within 5 years would
okay.
be going
That's
away.
A more qualified statement.
Yeah.
And maybe that has happened because of hesitation to hire. One thing we may see, some programmers need to crank out product.
Mm-hmm.
And I've said before, yeah, it kind of sucks that there's so many CRUD apps because writing CRUD apps is not all that fulfilling.
No.
Well, maybe we can reduce the drudgery on writing the CRUD apps, and there will be people who focus more on applying the software to the business at the line of business, at the departmental level, rather than having all of programming off in a separate kingdom called IT.
Yeah.
I think we will also find that for things that are critical infrastructure at the bottom of the stack, you're going to see AI-assisted programming, but it's still going to be human brains and human eyes on the code as much as or more than the AIs are touching the code.
Mm-hmm.
So we may see a kind of fractionation between, things that are foundational, high fan in versus things that are closer to the edge or closer to application layers.
Yeah.
That's a speculation. Seems to be how the forces would push things, but we'll see.
Well, that makes me think of my very first job, programming job in 1997. Whereas previous to that, I worked for a local school district, and school districts just did not have their own computer programmers. I mean, they had some machine operators to print report cards and other specialized machine, but they did not have they didn't have websites, right? That was brand new. And,
right.
And so I got hired to do it, and I was, 18 years old, and new technology came around that enabled somebody with no experience to actually do something really useful for a school district, which historically did not have a software department. And then, of course, cloud is another thing. Companies that previously had no access to a certain type of computing now had access.
Mm-hmm.
I think that's going to be repeated itself again, where, the big companies that have always employed thousands of programmers, okay, we'll see how that shakes out. But how many companies who had no access to have an employee that was a programmer now can say, wait a minute, if I have one of these on staff, even a super young, inexperienced one, now with these AI tools, wow, okay, now a different type of software is accessible to my company. Whereas before, I would talk to a consulting company, they would give me a price, and I would say, never mind.
You know what I find really interesting with those two examples you offered? In both cases, it was a sort of democratization of capabilities that used to be out of reach.
Mm-hmm.
And the net demand across the world increased dramatically with each of those steps.
Yes.
So if this is another massive democratization of software production capabilities, maybe net demand is going to increase again.
Yeah. And I'm not aware of any field at any time where the need for engineers went away. It seems like there are unsolvable problems across the world that are going to constantly need engineers to provide solutions for, regardless of, how the solution comes to be.
Well, partly because we keep pushing the frontiers of what's possible.
Yeah.
Every time something becomes fully solved, we just move on to a harder, more complex, larger, bigger scale, whatever.
Yeah, totally. Well, Michael, This has been a great conversation for me. Thank you so much for coming on the podcast. I really appreciate it.
My pleasure.
And until next time, dear listener, keep shipping.
You've been listening to the AI DevOps podcast. You can find us on YouTube, Apple Podcasts, Google Play, and everywhere else. Visit our sponsor, ClearMeasure, at clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.